Hello guys, welcome to my YouTube channel. So today I am going to show you how we can use logistic regression in our ML practices. So here I am just giving the name. Actually I downloaded this database from the Kaggle, so you can also download it from there and see how can we you perform the logistic regression on that. So this is the heart disease database, which is predicting that is that customer or the user has the heart disease or not based on the few practices. So now I just import this database. Now let me import few libraries which is required for us. So here is like pandas as pd. Again we import the numpy as mp. These are the default thing, we need to do that. So actually I am just giving you the hands-on and live environment, so you can also learn from it. You can use pyplot as plt, and always don't forget to use that like hashtag matplotlib, sorry, percentage matplotlib inline. This is for just making sure initialization will be smooth for the matplotlib library. We can't use hash here, we just use the percentage here. So this is the thing, right? So I just used imported this database and perform that. Many of the times you can see in the Kaggle, right, people are like uploading the database and the other people are uploading the notebooks, right? But there are the notebooks which are present, but they don't show you like how you can perform the code and how you can do the code. So in this video I am going to actually explaining the step-by-step approach how we can perform the logistic regression or any algorithm if you choose, how you can perform on the live environment. So here I am just using the read csv file, because you can see that I am just listing the file which is the csv file. So I am using the read csv. Also I am giving the path, so path should be the exact path. So because this file is present on my temporary directory which is like Kaggle cache directory, so that's why I need to perform these things. So if I can print those things, you can see that my database is ready. So you can see that I have like different columns, right? I have some database of the male, which contain male is equal to 1, which means that it's a male, and if it's a 0 it's a female. Age, education, and current smoker, cigarette per day, bp medicine. This is the parameter, like what is the blood pressure of the user. Again we have like prevental stroke, means is there any stroke in past. Prevental hyper, there is the one also parameter which is saying that the prevental hyper disease is present or not. Is and again one column is showing that the is diabetes is present or not. Total cholesterol, system bp, symbolic or something bp, this is the also one of the parameter. This is also the another parameter, dial bp or something like that. Also we have the bmi, heart rate, glucose, and 10-year CHD, means cardiac heart disease. So what is saying that we have to predict, our output variable is the 10 years CHD. It's like the, we can say, true or false variable. 0 is for there is no heart disease and 1 is for the heart disease, and based on this parameter we need to like the predict our output. So right now means in my previous video I explained that like why logistic regression, where the linear regression fails and logistic regression come into the picture. So in this video I am going to show you like hands-on demo how we can perform those things. So first of all, always we do check null values. So is in a, we can use some function. So you can see that there are some null values which are present on my dataset. In the educational column I have 105 null values. In the cigarette per day I have the 29 null values. Let's clean up the null values, because these are the distributed data analysis. We are using some statistical method to do that. So now let's do that. So here df dot like fill na or drop, we can use drop na, because there are only few values which are null values. So we can drop is also one of the technique we can do that. So drop na we can do that, and we use the axis here. Axis equal to 0 means row wise I want to delete those null values. So you can see that the null value is deleted, but this is not actually deleted on our data set. These are just we did for our for this command. So now if you want to do these things on actually data frame, you use the in place attribute. in place equal to true, which means that change the null value in the df. So it's, you can see that there is a 0 0, means no null value which are present. Now our like null value drop mechanism is successfully completed. Now let's do here. You can see that my education is not actually affecting my hurt or possible output, because if people is educated, still have the heart attack or still have the heart disease related issue, right? It's not depend on my education. So education is unwanted here, right? Because and in mathematical as well, I will show you how we can perform that. So we can use the correlation here. So if you can see that there is the negative correlation, or the in the education column you can see that there is like minus 0 point, means there is the negative correlation. But actually based on our data analysis we observe that education not affecting my heart disease, because if heart disease is not come based on the education. If this is the master guy, so I will not going to that master guy, only going to the bachelor level guy. These things is never happen. It's not a biased things, right? So we can drop this education column. So for dropping that we can use the df.drop function, and we use the labels. We can say label equal to, and education we can say use, and comma we can use axis. In this way we are using axis equal to 1, because I want to drop these things on the like column wise. So also we can, don't forget to use the in place equal to true. So this will actually affect our database. So now you can see that if I print those things, you can see that my education column wipe out. So now you can see that all other columns are required for us, because male and female is required, because male body is different and female body is different. So based on that we need to predict something. Also age is also required, current smoking, and all these parameters also required. Let's see the graph of this parameter, because what happened, we need to check what the data look like. So for that I use columns equal to df dot columns attribute to print the column. Now we use the column in columns, and here I am just plotting the histogram for this. Then we use the hist df of column, only this one, and df dot show. So it will print that. Let me also use the plt.axis x label to see what the parameter are on the, we use the column. So now you can see that there is this column is for the male and female, which means that we have 2000 male or some 1500 and something female. Based on this axis we can observe that. Also age is some we have the normally distributed data set. We can say this is the, because this has the forming the bell curve structure. Now the current smoker we have the yes or no, which is the also true and false condition. Also cigarette per day we have, some people are doing the 10, 20, 30, 40, and also there are some outliers which are present also as well. Now you can see that there is the like blood pressure. Some has the blood pressure with the 0, but some have some blood pressure, so it's a 1. It's a yes no type thing. Also prevental stroke. These things is very important, like we are doing the data analysis based on our data. Because we have to play at least half an hour on the data analysis, but I am not playing that much in this video. But you can also play and turn on that data. In that way you can get more insights, and based on that you can choose the strategies and perform the algorithm analysis. So now you can see that all my data is which are some of the normally distributed, some contain outlier, but we can accept that those outlier, because once our like error is produced, then based on that we come here and retrain our database and remove the outlier. Means these are the continuous cycle, right? Because we perform statistical analysis, then we apply in the predict something or train model, then we predict something, and then again if the prediction is wrong, then we again do an analysis again, then we are again training the model and things like that. This is the cycle, right? So we need to perform that in cyclical way. So now you can see that my null values are removed, and my graph is also, I saw that. Let's split our database. So for that you can use import sklearn dot model selection method, import train test split we can use. Okay, I'm not sure like where the train test split method is present. Let's go to the internet. So we can use the train test split in sklearn. So if I do that, if I do that, you can see that I got the first documentation which is saying that this method is present in the model selection class. So I use here is everything is correct. We use train. Where I miss? Okay. Actually, I missed something here. The syntactical way I use the from here, from sklearn import train test split. Now my method is successfully initialized. Let's me do like -x-train, x-test, y-train, y-test equal to train test split. Now I am using the df, but you can see that, let me print here the df dot here. You can see that this is my df, right, which contain input variable is up to the glucose, right, and my output is only one this column. So how we can do that? We use the ilog function here. So we use the ilog, give me the all rows, comma, give me the column till -1, means except my last column. Give me all the columns except my last column in the as a part of x. As a part of y, give me ilog. We can use again the use ilog. Then again we can use all rows, comma. Oh, first colon is for the all rows. If I want to row for 1 to 5, then we use something like this. But I need all rows, so all the rows of database. So here we can use -1 only, because I need a row up to -1. Means only the -1 row. I only the -1 column give me, other column never give me. Don't give me to give it to as a part of y. So it's we are done with this. Now use the test size. Test size is 0.2, comma, shuffle equal to true, and stratify. Actually about this stratify parameter I explained in the video, in my past video. You can see there about that stratification in the train test split video. So you can check there and get the like your everything. So for the stratification we can use df of male. Now our train test split performed successfully. Now see the shape of this, because shape is always required. So just to see that is that our splitting happens successfully or not. Then y dot train dot shape, comma, y dot test, comma, shape. Now you can see that I have like 2924 rows in my test, in my train, and 2924 rows in my y train. But in my test you can see that I have 732 rows and 14 columns, but in my y train y test I have 732 rows and 1 column. Here is nothing, which means 1 column. So now my train test split happened successfully. Now let's go for the linear regression directly. So then we can use import sklearn, from sklearn dot linear model import logistic regression. Logistic regression. So this is about the logistic regression, right? So it's for the categorical database. So now you can see that I successfully imported this class. Let's initialize this. Let me use regression equal to logistic regression, and I'm just using the blank or the default one. Now you can see logistic regression dot fit method. In the fit method I use x train, comma, y train, and it will train my model. So there are some like warnings and things like that, because we are using the default one, so that's why, but we can ignore those. Our model trained successfully. Let's print the coefficient of regression and intercept of the regression. So you can see that I have intercept around -0.4 and coefficient, I have some coefficient, right? So let's predict something, or let's pass the test database to it. So we can use predict method here, which contain y test, and here y tends to predict equal to regression dot predict. So it is predicted my model. Now I have the train test data set which contain test x and test y, and also I have predicted database. So let's compare our predicted and our actual test. So how we can do that? We use the mean square method, but for that we need to import from the sklearn library. You use the matrices class from the sklearn library and import mean square error, mean underscore square error. You can see that my error is successfully imported. This function is successfully imported from the matrices class. Now let's pass the actual y comma predicted y. Now you can see that my error is 0.15, which is close to 0, means not like far away from 0. It's not a 1 2 3 5 10 or something like that. It's close to 0, so we can accept this error. Also let's test it for the there are two parameters for error testing: mean square error and mean absolute error. So we can use for mean absolute error as well. What is the parameter look like? So I'm just using the same one. So you can see that for my mean absolute error, we can see again 0.15. So in our logistic regression, everything performed successfully and we got the minimum level of error. If my error is close to 0, it's close to 0, it's not actually 0. If it's become actually 0, then it will create the problem of overfitting. So I accept those error and see that my logistic regression I perform on the successfully. So based on this database, if you want to perform something like if you want to predict something, you can also use the predict method here, regression and predict method, and pass your custom things, and based on that this machine learning model will predict that you have heart disease or heart disease rate or heart failure rate, what is that you have or not. So you can also perform these things, and based on that you can predict your own output values. So that's pretty much in the side of logistic regression. I hope this video likes you, or this video helps you more regarding a hand-on thing. Actually I go one by one step, because I also want you to learn from this, to seeing that if I can like write this code already and explaining to you, that will not give you the runtime idea, like what happen if the error comes and how to solve the errors and things like that. So that's why I'm giving you the exact way how you can perform the logistic regression, and if you are stuck, then how we can solve the errors and things like that. So that's pretty much from my side. Thank you so much.